Sarah, back in 1940, the US Army had a huge problem. Modern warfare needed constant coordination, but their battlefield radios were practically useless.
What was wrong with them?
They were unreliable, used AM technology, which was crippled by static and engine noise, and their range was terrible. Officers often preferred sending runners with messages which were slow and dangerous.
That sounds incredibly inefficient, especially with war looming.
It was. But in September 1940, an engineer named Daniel Noble joined Galvin Manufacturing Corporation, which later became Motorola. Noble was a pioneer in a different kind of radio technology.
What technology was that?
Frequency modulation, or FM. He had just built the first statewide FM radio system for the Connecticut State Police, and he knew it was vastly superior to AM for clear, reliable communication, especially in noisy environments.
Galvin Manufacturing already had some success with a small handheld AM radio called the SCR-300, nicknamed the Handy-Talkie.
I've seen pictures of those. They look like a big telephone handset.
Exactly. They were innovative for their time, truly portable, but they had one massive limitation.
Let me guess. Range?
Barely a mile under good conditions. That's okay for talking within a platoon, but useless for coordinating between companies and battalion headquarters several miles away, or for forward observers calling in artillery fire.
So it left a huge gap in battlefield communication.
A critical gap. The Army knew they needed something better, something portable but with much greater range.
So the Army asked Galvin Manufacturing to build this new, longer-range radio.
Yes, the Signal Corps issued a contract, but there was a catch. Based on their experience and existing infrastructure, they specifically mandated that the new radio use amplitude modulation, AM technology.
The same technology that was already proving inadequate?
Precisely. When Daniel Noble learned this, he did something incredibly bold, especially for an engineer talking to military procurement officers.
What did he do?
He told them flat out that specifying AM was a grave mistake. He insisted the new radio had to be built using FM.
He basically told the Army their plan was wrong. That must have been risky.
It was hugely risky. He was contradicting the established military preference, advocating for a newer, more complex, potentially more expensive technology that many engineers considered impractical for portable military use.
Why was FM considered impractical?
Well, FM circuits were more complex than AM, raising reliability concerns. It also required a wider bandwidth, meaning fewer channels could fit into the radio spectrum, which was already seen as crowded.
So AM was the safe, known quantity. Why was Noble so convinced FM was better, despite these drawbacks?
Because he understood its fundamental advantages for the battlefield. FM naturally rejects static and electrical interference, noise from vehicle engines, thunderstorms, other equipment that would drown out an AM signal.
So, clearer communication in the chaos of battle.
Much clearer. And FM signals don't fade into static at the edge of their range like AM does. They stay clear until they drop off completely. Noble had seen this work with his police radio system. He knew FM was the key to reliable communication when it mattered most.
Did the Army listen?
Amazingly, yes. Noble's passion, technical expertise, and proven track record convinced Major O'Connell at the Signal Corps. They took a gamble and awarded Galvin a contract to develop an FM portable radio, designated the SCR-300.
Noble assembled a brilliant team back in Chicago, including a key engineer named Henry Magnuski. But the specifications the Army laid out for the SCR-300 were incredibly demanding.
More than just being FM?
Far more. It had to be battery-powered and weigh no more than 35 pounds, light enough for a soldier to carry on his back while fighting.
That's a tough weight limit for 1940s electronics and batteries.
Extremely. It also needed a reliable range of at least 3 miles, sometimes through forests or over hills. It had to be water-resistant, simple enough for minimally trained soldiers to use under fire, and tune across a specific frequency range.
And there was one more major constraint, wasn't there? Something about crystals.
Yes, and this was a huge challenge. It could use no more than 2 frequency control crystals. Crystals were essential for stable frequencies, but producing them was a major bottleneck in wartime. Limiting them to 2 while still needing multiple channels required incredible ingenuity.
Noble gathered his core team, including Magnusky and a young engineer named Andy Affronti. He laid out the Army's specifications, emphasizing the urgency.
He told them it was a life-and-death priority?
Those were his exact words. He stressed that soldiers' lives depended on this radio working. The pressure was immense, but the team dove in.
How did they tackle those seemingly impossible requirements?
Through a series of revolutionary design choices, all enabled by the inherent advantages of FM. They knew they had to make it simple for the soldier.
What was the first big innovation?
A single tuning control. Instead of separate knobs for transmit and receive frequencies, they devised a system where one knob tuned both simultaneously. It was technically complex, but made operation under stress much easier.
What other breakthroughs did they achieve?
They incorporated automatic frequency control, or AFC. This circuit automatically locked on to the correct frequency and kept it stable, preventing drift due to temperature changes or battery fluctuations.
So the soldier didn't need to constantly fine-tune the radio while fighting.
Exactly. Another critical feature was the squelch circuit. With AM radios, operators endured constant background hiss when no one was transmitting, which was fatiguing and made it easy to miss the start of a message.
Squelch silences that background noise, right?
Yes. The receiver stayed quiet until a signal came in, making transmissions instantly noticeable. They also designed highly efficient circuits to maximize battery life, meeting the weight and endurance specs.
And how did they solve the 2-crystal limit while providing multiple channels?
Through clever frequency synthesis, they used the 2 crystals as reference points and designed a variable tuning mechanism that could accurately generate 41 distinct channels across the required frequency band, using harmonics and precise calibration. It was an elegant solution.
By the spring of 1942, the team had 2 working prototypes. The moment of truth arrived during testing at Fort Knox, Kentucky.
Did they meet the 3-mile range requirement?
They obliterated it. Magnusky and Affronti stood 8 miles apart. Magnusky transmitted, and Affronti heard him with perfect static-free clarity.
8 miles? More than double the specification.
And it wasn't a fluke. They tested different frequencies, different locations. The prototypes worked flawlessly every time.
The Signal Corps must have been ecstatic.
They were deeply impressed. But the ultimate test came during the formal acceptance trials, also at Fort Knox. The highly critical infantry board, known for rejecting equipment, was invited to observe.
High stakes.
Immensely. But the production-ready SCR-300, now officially nicknamed the Walkie-Talkie to distinguish it from the smaller Handy-Talkie, performed perfectly. It cut through vehicle ignition noise, it survived rough handling and rain.
And the infantry board?
They gave it their enthusiastic approval, recognizing it as a game-changer. Full production was authorized. Galvin, soon to be Motorola, would produce nearly 50,000 units during the war.
The SCR-300 made its combat debut in the Pacific on New Georgia in August 1943.
That dense jungle terrain must have been the ultimate test for radio signals.
It was. The theater signal officer, Colonel Ankenbrand, had actually protested getting the SCR-300. He believed its VHF signals wouldn't penetrate the jungle effectively and preferred lower frequencies.
But he was wrong.
Completely wrong. The FM signals performed surprisingly well, cutting through the interference and vegetation better than expected. By January 1944, Ankenbrand was writing rave reviews, calling the SCR-300 exactly what is needed for frontline communication in the jungle.
What did the soldiers carrying them think?
They loved the communication capability. Their main complaint was actually the harness design, which wasn't very comfortable on long marches. But the radio itself? One communications officer called it an infantryman's dream.
It also proved its worth in Europe, didn't it?
Absolutely. It saw its first European use during the invasion of Italy in September 1943. Operators waded ashore under fire and immediately established vital communication links,
Allowing commanders to control scattered units during the chaotic landings.
and crucially, allowing forward observers to reliably call in artillery fire. The clear FM signal meant coordinates could be transmitted accurately, fire missions executed quickly. It fundamentally changed artillery support.
The SCR-300's impact became even clearer during major operations like the Normandy landings in June 1944.
The beaches must have been an electromagnetic nightmare with all those vehicles and equipment.
An AM radio would have been useless, drowned in static. But the SCR-300's FM signal cut right through it, allowing crucial coordination during the landings and the push inland through the difficult hedgerow country.
Did they use that relay function you mentioned?
Extensively in Normandy, setting up two SCR-300s to automatically retransmit signals allowed headquarters to maintain contact with forward units miles away, even across hills and hedgerows that blocked direct signals.
And its most crucial test came during the Battle of the Bulge?
Arguably, yes. In that chaotic winter battle, with units cut off and surrounded, the SCR-300 was often the only lifeline. It allowed isolated units to coordinate defenses, call for artillery, and maintain contact with higher command,
preventing disintegration and enabling the eventual counterattack.
Many officers later called the SCR-300 the single most useful piece of communication equipment in that battle. It wasn't just a radio, it was a command and control system that gave American forces a decisive edge. Daniel Noble's forbidden insistence on FM technology had delivered a war-winning advantage.